This is Indian Point nuclear reactor. It's got 2 operational units and it produces about 12% of the power for New York, the state of New York. It's a large building, but this is only about, well, less than a square kilometre of land here, occupied by the whole power plant. You can see the car park here for scale. And also over here, all of the spent fuel that it's ever produced throughout its entire existence is stored right here. That's mostly concrete and steel, to be honest, with a bit of nuclear waste inside. Now, nuclear is carbon free, essentially, and it's great that New York has had this, but it's being prematurely closed. This reactor probably has a good 20, maybe even 40 years left in it. It's not unheard of now for reactors to receive an 80-year operating license from the NRC. Well, this one's only had its first 40. And it's being closed. Realistically, this is premature. It could be producing clean energy for a long time. But hey, okay, it's being closed. Let's see if we can replace this with something like solar. So let me go over to this. This is Topaz Solar Farm. This is out in the desert somewhere on the west coast, nowhere near New York. New York doesn't really have deserts, but this is, so if I just go over here, it's about a 550 megawatt capacity solar farm. That means when the sun's shining, when there are no clouds, it'll produce 550 megawatts. Of course, there is nighttime and there are clouds, so what you get is an average. This is known as the capacity factor, and its average generation is basically 26% of that. So that's 140, whatever. I've done it side by side, so 146. That's what its average is. So what that means is you need 14 of these to get the same amount of power that you would get from, let me zoom in, this is Indian Point here, which is 2,144 megawatts. So you need 14 of these to get the same thing. Now we go over here. This is what that looks like. I've just copied it 14 times, and in the middle, these are all to scale. In the middle, here's your Indian Point. Just to show about the scale, back to this one, well, here's your 1 kilometre scale bar. Let me just drag this over. You can see the 1 kilometre scale bar on the solar farm there as well. I did my best. It's basically to scale. So that's a lot of land. If you wanted to replace this reactor with solar, you'd need a lot of land. Now there's a lot of green around New York, and yeah, you can put solar on all these rooftops, which I think we should do anyway. But if you replace this reactor with solar, you're just cannibalizing one form of clean energy with another. So this shouldn't be shut down, in my opinion. Now, this is what's going to happen. You see these brown, back in 2005, these brown colours here, these are petroleum and coal. And you can see that petroleum and coal have been phased out, basically almost completely phased out by 2015 in New York. And what stepped in to replace them was this orange on the top, this natural gas. This is exactly what's going to happen for Indian Point when Indian Point closes. If I go over to here, so nuclear power produces about 12 grams of carbon dioxide per kilowatt hour, and this is throughout its whole life cycle. So actually a lot of that comes from the construction of the plant, and this takes into account the decommissioning at the end. So really during operation the only source of carbon dioxide is from the manufacturing of the fuel, which is quite low. But on the other hand, natural gas is about 490 grams of carbon dioxide per kilowatt hour. So what New York is doing is taking an incredibly clean source of energy, and they will replace it with natural gas essentially. Yes, solar and wind will ramp up slowly, but that's going to happen anyway, so it should. But really the day that plant closes, there's going to be more gas being burned. Now it's a good thing that gas replaced coal, but replacing nuclear with natural gas is a massive step in the wrong direction. And I know change.org petitions, yeah, say what you will, but there's a petition that will take 5-10 seconds to just click, and if you watch this and you think I'm talking sense, it might be worth clicking. Cheers.